Hey guys, in this video, I'll show you the fuses to check when the engine is not cranking on a Toyota Corolla. Then we will remove the starter relay and do a quick test on it to make sure it's working properly. So we will start by opening up the fuse and relay box, which is located on the driver's side of the engine compartment. The back of the lid has a diagram with the component locations. Make sure to check this first, since component locations can vary between models. So we have two fuses to check here. First is the starter fuse, which is labeled as ST on the diagram. When this fuse is burnt out, the starter will not receive power while trying to start the car, so the engine will not crank at all. If the engine does crank, even for a second, or the starter makes a ticking noise while trying to start the car, then that means this fuse should be okay, and the problem is likely a low battery or a corroded battery connection. If the starter fuse and battery are okay, and the engine is still not cranking, then there's one more fuse to check, and that's the AM2 fuse. This fuse protects the ignition switch, so when it's burnt out, turning the ignition switch to start will not energize the starter relay, so the engine will not crank at all. Let's move on to the starter relay now. When it's faulty, it will also cause the engine to stop cranking, and it's labeled as ST number 1 on the diagram. Before removing it, the car should be turned off completely, and the negative battery cable should be disconnected. And now to remove it, I'll remove the two relays below to make room, and gently wiggle it side to side and pull up. Relay pulling pliers can also be used instead, and I'll have a link to them down in the video description. Once the relay's out, make sure to handle it with care. Do not drop it on the ground to prevent damage. And now I'll reinstall the nearby relays in the same location as they were before. Some relays in this box handle more power than other relays, so it's very important to make sure that they're installed in the correct position. Alright, so we got the relay out. Now we can do a quick test on it to make sure it's working properly. I will apply 12 volts to the coil pins, and we will check the resistance between the load pins at the same time. When power is applied, the resistance should be almost 0 ohms, and when it's not powered, the resistance should be infinity. This is a 12 volt relay, and I'll power it with a 12 volt power adapter, which has short circuit protection. For safety, it's important to protect the power source being used in case the relay is shorted out. If the power source doesn't have built-in protection, then a 1/2 amp fast blow fuse can be placed in line on the positive side to protect it against short circuits. And now I'll set the multimeter to test for continuity, and we're ready to test the relay. So let's give it a try. I'll plug in the adapter, and as soon as the relay was powered, resistance dropped to almost 0 ohms, and anything that's really close to 0 means that the relay is working properly. If the resistance is not really close to 0, then the contacts inside the relay could be corroded, or the measuring equipment may be faulty, so make sure to test the multimeter by touching the leads together, and the reading should be very close to 0. Now let's remove power, and the resistance is over limit now, which is normal, so this relay is working as expected. In case the relay doesn't work as expected, check the side of the relay to get the part number, and make sure to replace it with exactly the same type of relay. If you found this video useful, please make sure to give it a thumbs up. Your support is really appreciated, and consider subscribing to my channel. I will have more videos coming in the future. Thanks for watching!